Okay, so this section is about solving separable equations. Now, here's where we actually tell you what is a separable equation. So remember that most differential equations can't be solved analytically, or at least in terms of elementary functions. So similar to integrals in a way, right? There's a lot of differential equations that you're just not doing them by hand, okay? But there are some classes of equations that are easy to do by hand, and separable equations are are a class of differential equations of which we can solve most of them by hand. We'll talk in a later video about what can go wrong. But for here, we're only going to be talking about what can go right. So I'm going to start by reminding you, what does a general first order differential equation look like? General first order. All right, that's a Star Wars joke. But a general first order differential equation looks like dy dt equals some function of the independent variable and the dependent variable. Okay, and that can look like anything. Any mixture of t's and y's that you can think of. T squared times the sine of ty plus e to the e to the e to the e to the ty cubed power, right? It's just any nonsense of t's and y's and a derivative. Okay, but specifically we're going to talk about a separable differential equation. So again, this is just, you know, a general first order ODE. First order, again, referring to the fact that this is the first derivative. So a separable is of the form g of t times h of y. Why is this called separable? Well, I think you might be able to see it, is because, well, we'll talk more about why, but the idea is you can divide out the t's. Oftentimes we actually divide out the y's. We can divide out the y's to get the y's over here, and then we can get all the y's on one side, all the t's on one side, and we can actually integrate. Okay, so before we actually do that, before we solve separable differential equations, let's get some practice. So again, it's separable if it can be split up as something with only t's times something with only y's. And again, the variables may variable. I am really full of great ones today. So let's do an example. Which of these are separable? So similar to the video before, I want to write down these equations, and I want you to pause the video and think about them and solve them, and then we'll go through them together and see if you got the right answer. So dy dt equals y times t. Is that separable? Y prime is equal to y plus t. Is that separable? And remember, we can write differential equations with different notation. P dot, remember we use the dots if the derivative is respect to time. T plus 1 over tp, I'll keep my mouth shut, plus t. And finally, the last thing I want you to look at is dx dt, pretend that's an x, equals some function of x. And I haven't told you what this function of x is. So pause the video right now, decide which of these are separable, which are not. Okay, so remember, is there some function of t times some function of y? If so, it's separable. Yep, some function of t, some function of y. This is separable. Okay. Is this some function of t times some function of y? No, it's some function of t plus some function of y. And in fact, there's no way to have this be two things multiplied by each other. Even though you might think we can subtract it over, it's not exactly separable. Again, separable has to be multiplication, not addition. So this one is going to be a no. The next one doesn't look like it is, but if we fiddle with it for a little bit, right, we can factor out that denominator, factor out a t, and we're left with p plus 1. And if that's the case, can we not write it as t plus 1 over t times 1 over p plus 1? Is that not the same exact equation? Is that not something with t's times something with p's? It is. That's a yes. This last one's interesting because there are no t's. So what do you think that one counts as if there's no t's? Well, we can write this as times 1. And then, yeah, there's something with, well, there's t is not our independent variable, right? But here, so our independent variable here is x. So here's a function of x. It's a constant function, but sure, it's a function of x. And here's a function of our dependent variable. This last one is what's known as an autonomous. I can't smell autonomous. Autonomous differential equation. And what autonomous means, right, is that the right-hand side has no independent variable. And honestly, we've mostly been dealing with autonomous ODEs so far, right? If you think back to, well, if you think back to the previous section, which I don't have written down, then it was autonomous. Basically, everything was autonomous. None of the this one's autonomous, right? There's no. All right, sorry, it's the differential equation, not the solution. This is not autonomous, right? The differential equation has the independent variable. This is not autonomous. The differential equation has the independent random variable. But section 1.1 had a lot of autonomous equations. So that's pretty much it. We now know how to classify something as separable or not. And yeah, that's all this video is. We'll talk about how to solve separable differential equations in the next one. You will be able to solve your first differential equation yourself, and it won't be that bad, assuming you remember Calc 2. All right, Calc 1 and Calc 2 going to be very important for this class. Good luck. Bye-bye.